frame. In the first part of this video, I have discussed until step number 2. Okay, step number 2 is actually part 1. It is no sidesway frame analysis. So in no sidesway frame analysis, there are 3 steps that we have to do. Number 1, we will calculate FEM due to external loading. External loading in this case is 30 kilonewton per meter UDL, which is loaded along member AB. So this will give us the FEM due to external loading. FEM due to external loading, and this is the first member and moment in the table. Okay, so from the FEM means the first member and moment in the table. So we will put into the table. So in the table, of course, we have to calculate distribution factor. We have to calculate K and distribution factor because we will distribute moment using distribution factor. And after that, from the end moment, the 6th end moment, because this frame has 3 members, so one member has 2 ends, so there are 6 end moments. So all 6 end moment we get from the table. So from the end moment, from each end moment, we will continue to calculate restraining force R. Okay, actually we apply the principle of superposition. We apply the principle of superposition whenever the frame is sidesway frame. Sidesway frame is a condition whenever the frame is unsymmetry. The frame is unsymmetry. So looking at the frame, the geometry of the frame, the loading as well, how the loading is subjected in the structure in the frame. So it is unsymmetry frame. Unsymmetry frame is sidesway frame. So in order to calculate the fixed end moment for this frame, we have to apply principle of superposition. Principle of superposition. In principle of superposition, the idea is because we have to calculate a fixed end moment 2 times. One is due to external loading, where the value is given, the 30 kilonewton per meter UDL is given. So we can calculate FEM due to external loading. But for frame with sidesway, the delta is unknown. So we cannot calculate the FEM due to delta in this case. So that's why we apply principle of superposition, and that's why we have to have 2 parts. We have one table calculating only external loading, based on external loading, and another one is only due to sidesway. So this is the principle of superposition. So the idea is we have to separate between W and delta. So to remove delta, we have to put an artificial support at C, because this frame, we assume it is moving towards right direction. Of course, the sidesway can be left or can be right, but we can assume that the frame is moving towards right direction. So we have to put the artificial support at point C. So by putting that support, there will be a horizontal reaction we call as restraining force R. So by having this pin and the restraining force, the frame in diagram B is now a properly restrained frame. Properly restrained frame is no sidesway frame. So we will focus on diagram B for step number 2 here. Step number 2 here. And end moment from table number 1 is labeled as M0, and then we have to calculate the restraining force. So how to calculate the restraining force? So this is the table. So as usual, in the table we have to calculate K and distribution factor, and then using the 30 kilonewton per meter UDL along member AB, we get negative 90 and 90. So we put into the table, and we complete the moment distribution. This is table number 1. Table number 1. So we do distribution process, and then we carry over the value. Remember, for the factor, the carryover factor is all 0.5 in this case. Okay, we have the factor 0 whenever the n is spin. That is 0 carryover factor, but now it is all 0.5. Okay, so all six total moment that we get from table number 1 is actually the end moment, the 6 end moment. So 6 end moment acting like we have here. So for AB, MAB, so MAB, it is negative, so we put negative. MBA positive, we put positive. So this is all end moment, 6 end moment. Okay, and after that, because we have to calculate the R value, and R is in horizontal direction, so we have to have one equation, and in the equation it must have R. So it is total fx is equal to 0. We call it as shear equation. Shear equation. So when we write the shear equation, we have to consider diagram B. We have to consider also all horizontal forces and horizontal reaction in the diagram. So we write one equation. So from this figure, from the figure as shown in the screen right now. So we write one equation. It is 30 plus AX plus DX. Of course, AX and DX we can put in any direction, and we will write the equation based on the direction that we put. Okay, so in this case, I put both AX and DX in right direction. So it is positive AX, positive DX. And R is negative R. Negative R, the restraining force, this is equal to 0. Okay, so from this we get R. We can get R. So how to get R? Whenever AX and DX. Whenever AX and DX are calculated. Okay, we have to calculate AX, we have to calculate DX, then only we can get R value. So calculating AX and DX is actually static equilibrium equation. It is just by applying equilibrium equation like what we do when we analyze simply supported beam. So in any structure, when we want to calculate okay, when we want to calculate the reaction, okay, the forces, we can apply equilibrium equation. So we apply equilibrium equation in and in the element in column AB, column CD, because from analysis of column AB, we can get AX. Analysis of column CD, we can get DX. So that's what we actually do. So we consider column AB. We consider column AB. So we we just take out member AB. We put moment that we get from the table MAB and MBA. We put the right direction that we get. Is if negative, we put counterclockwise direction. Okay, if it is positive, we put clockwise direction. And then AB has UDL, so UDL 30 kilonewton per meter. And we put AX, and this AX, we follow the direction from this diagram. Because this direction we use to write the shear equation. Okay, so from this element, this column AB, by applying moment at B, total moment at B is equal to 0, we will get AX value. This is just like we calculate reaction in simply supported beam. The difference is beam is horizontal member, and this AB is vertical member. It is column. So from that we can get AX value. So we do the same thing for column CD. Okay, for column CD, we apply moment and moment MCD and MDC. And then we put DX. We put DX direction, we have to follow this. We have to follow this direction. Okay, so then to calculate DX, we have to apply moment, total moment at C. Total moment at C is equal to 0, taking moment at C. So from this we can get dx. So now we have already got AX value, DX value. Then we just need to substitute AX and DX into the shear equation to get R. So we just put the value into the shear equation, then we get R is equal to negative 68.748. It is negative 68.748 kilonewton. This is the restraining force. Okay, so this is actually no side sway frame analysis, part 1. Okay, we are now moving to part 2. Part 2, we focus on side sway frame. We will consider side sway frame only without having any external load. Okay, so it is actually based on the principle of superposition. So we are going to start part B now. Part B. So what is part B? It is side sway frame. Part B is side sway frame. Okay. In side sway frame, okay, recall back. We just need to recall back. So original is like this. Original. Okay. And this is equal to R here. Due to artificial pin support at C. And this must be neutralized. So we have this. Okay, this is due to R. Okay, means that we have this is actually principle of superposition. So this is diagram B, diagram C, this is A. Okay, table number one based on this. This is table 1, where we can calculate FEM due to 30 kilonewton per meter W. Okay, however, can we calculate FEM for table for C? It is cannot. Okay, we cannot calculate FEM for diagram C directly. We cannot do that because the delta is unknown. So actually, in step number 3, it is called as side sway frame analysis. Okay, this is actually part 2. For side sway frame analysis, we have to do 3 steps. Okay, number 1, we will calculate FEM. But this FEM will be based on assumption of FEM due to delta prime. And then from that we will get the table, and we use the FEM in the table, and then we calculate member and moment. So member and moment in table 2, the total, we label as M prime. M prime. Okay, because A is delta prime. So the end moment is M prime. From M prime, we will have restraint. This is R prime. R prime. So all label that we use in sidesway frame analysis will be based on prime. Delta prime, M prime, R prime. Delta prime, M prime, R prime. So if we try to compare back with diagram C, there is no prime. There is no prime. So how this prime appear? Okay, how is it? Okay, delta is unknown. The delta is unknown. And we cannot assume FEM with unknown delta. The delta shown here in this diagram, this delta is the right one, and we do not know this value. Okay, and we cannot assume this value. So what we actually do is we introduce another diagram which is proportional with the diagram C, which is proportional. So we have to introduce diagram D. It is a frame subjected to R prime. Due to that, there are delta prime at B, delta prime at C. Okay, so we have to introduce another frame. So we have to introduce same frame, but this time the frame is subjected to R prime. Actually, between diagram C and D, it is the same loop, but the difference is only to prime. If in C, it is R. In D, this is diagram D. In D, the R we have to put R prime. If in diagram C, it has delta, in diagram D, we have to change the delta to delta prime. Delta prime. The same loop, but we have to put prime. The same loop. Okay? And moment for diagram D. And moment for diagram D is M prime. M prime. So everything related to diagram D, we put prime. R prime, delta prime, N prime. This is also artificial frame. We do this because we will assume the value of FEM for D, not C. We cannot assume the real thing. C is in real, but D is artificial. So under this step, we have to assume FEM. Means that we cannot assume based on the real one, but we can assume the artificial one. So we have to assume FEM based on diagram D. So table number 2 is actually based on D diagram, not C. So this is table number 2. So sidesway frame analysis is actually referring to diagram D. So this is part 2. So part 2, sidesway frame part 2. We have to assume FEM. Okay, we have to assume FEM. So we have FEM due to delta, the formula. the formula, and FEM due to delta is is given, the formula is given. It is 6EI delta over L squared. That is the formula, 6EI delta over L squared for far and fixed. Okay, what we actually do here is we will assume FEM for one member. For one member, we have member AB, member BC, member CD. We have member AB, member BC, member CD. And due to the horizontal displacement, side sway is horizontal displacement. The member, the member that contribute to the side sway is only column, not beam. This frame, two vertical column, contribute to the delta prime, but not beam. So we assume, so we have to analyze column AB, we have to analyze column CD, okay, and then we continue to calculate M prime. Okay, so what we need to do is we have to assume FEM. We have to assume FEM for member AB, for one member. We can choose AB, we can also choose CD. Okay, but let's choose FEM for member AB. So assume FEM for member AB. FEM, FEM for member AB. And both will have moment. So FEM BA as well. So FEM AB, FEM BA. And this value we assume negative 100 kilonewton meter. So this is the assumption that we made. Assume FEM for AB and BA. And both AB and BA, the moment, the fixed end moment is negative 100 kilonewton meter. So why we have to put negative? 100, the value, actually it is just assumption. We can assume any value, doesn't matter. But the value that is suggested in the textbook is 100. But the most important part, important things here is the sign that we use, because the sign that we use for FEM representing the side sway, representing the behavior, Okay, FEM is behavior. Okay, it behave like this: original before side sway, column after side sway. Original is horizontal. Original column is vertical. After side sway, it is inclined. The behavior give us the moment. Okay, and the moment, the moment is actually the reaction. The moment is actually the reaction to counter back. The moment, the FEM is actually the reaction. The moment to counter back. Okay, means that when we apply moment, to push back the column to original position. Okay, from vertical. Okay, this is original. This one is original position. AB. After side sway, okay, the frame become inclined. The column AB become inclined. So moment, the fixed end moment we will apply the moment to push back point A and point B, so that it is go back to straight position, to vertical position. So we have to apply moment counterclockwise for both AB and BA. Okay, because if we put, for example, what happened if we put moment this direction, clockwise? What happened? Okay, what happened? We push this green line to this position, which is cannot. Okay, because moment we apply it is reaction to push back the column to its original position, and its original position is vertical. So if we apply moment clockwise, we push the column to be horizontal. This is horizontal, right? This is horizontal. This is horizontal. Horizontal is not column. Column is vertical. This is vertical, right? This is vertical. Vertical. So when we apply moment, we have to push moment. We have to apply moment to push back the column to vertical. We don't want the column to be horizontal. So that is why we apply moment counterclockwise. And counterclockwise is negative. Counterclockwise is negative. Okay, so that's why when we apply moment, fixed end moment, we have to consider the behavior because it represents the side sway. Side sway moving towards right direction. The assumption must be made negative because it is counterclockwise. Counterclockwise. Okay, so the assumption is negative 100. Okay. So now we apply the formula. So FEM for AB is equal to FEM for BA. This formula is 6EI delta, but this time we use delta prime. So we put delta prime over L squared. That's the formula. L is 6. L is 6. Okay, L is 6. Over L squared. Okay, okay. So this is negative 100. Okay, this is negative 100. EI constant. EI for AB is EI constant. Delta for AB is delta prime. L for AB is 6. So this is equal to negative 100. 100. Okay. So from this, actually, this is based on what Hibler says in the textbook. So we find EI delta prime. This is negative 100 times 6 square. We divide by 6. EI delta prime is equal to negative 100 times 6 square divided by 6. Then actually we use this in the formula of FEM for member CD. So FEM for CD is equal to FEM for DC. CD and DC, look at the diagram. Look at the diagram. This one, and this one, same behavior. Same behavior. Okay, F for the formula, 6 EI is constant, 6 EI. Delta also delta prime for CD, delta prime, but L is 7. L is 7. Okay, so it is 6 divided by 7 squared. EI delta prime, this we substitute. Okay, when we substitute, it is negative 100 times 6 square divided by 6. So we solve this. We solve this. We solve this, we get, so this 6 will be cancelled. Okay, we solve this, we will get 136 divided by 49. It is negative 73. It is negative 73.469. 469, this is kilonewton meter. Okay, this process, okay, is actually based on what we call as ratio. Because in the formula, it is based on EI, it is based on delta prime, and it is based on L. This is the factor that can influence the FEM, 6 EI delta prime over L squared. Okay, and in this case, if EI is constant, means EI is 1. If EI is not constant, then EI will contribute to the FEM. Delta for AB and delta for CD. Delta for BC is 0. There is no vertical displacement. So we just need to focus on the delta occur for each column AB and column CD. So delta for delta, okay, we do it one by one. Okay, this is for AB, this is for CD. Okay, EI for AB is 1. EI for CD is also 1. Because EI is constant. Delta for AB is 1. Delta prime for CD is also 1. We assume that both AB and CD have same delta prime, 1. Okay, L for AB is 6 meter. And L for CD is 7 meter. That is why in the video, in example 1 video, in the landing page, okay, example 1, the assumption is negative 100. Then the assumption is negative 100 for AB. After calculation, CD also negative 100 because all ratio is 1. EI is similar, delta prime is similar, length also similar. But in this case, length is not similar.